Now today the nonlinear programming with inequality constraint. Now before going to the detail of KKT conditions, I will just talk more on the feasible direction and other things. That is why let me just recapitulate the concept I told you in the last class, that is there are 3 constraints G1, G2, G3. This is my G1, this is G2 and this is G3. Now the objective function is moving in this direction. Our problem is to find out minimization of f subject to G1 less than is equal to 0, G2 less than equal to 0 and G3 less than equal to 0. If this is the level curve of the objective function f, that means objective functional value is increasing in this direction, and at this stage once objective function is coming here, we are getting the optimal solution x star. Okay. Now, if this is the optimal solution, you see from here we can draw that this is the grad direction, grad f direction, because objective functional value is increasing in this direction. Okay. Now, if we consider G1 equal to 0, this one, then this must be grad G1 direction, okay, and this is minus grad G1. Similarly, if we consider G2 direction, this one, then this is minus grad G2 and the opposite direction is the grad G1. Now we are talking Z2. Now we are talking about the feasible direction. Now this is the feasible space. That is why from here, if I just move this way, then this is the direction of the feasible direction, and if I move within the space anywhere, then this is the feasible direction. That is why this is a feasible direction, this is a feasible, these are all the feasible directions. There is no doubt about it. These are all the feasible direction, these are all the feasible directions with the green. Okay. Now, if I consider that this is one of the directions, say S. Okay. Now, in the last class, I showed you that if we consider the feasible direction S, then grad f is equal to minus lambda 1 grad G1 minus lambda 2 grad G2. Okay. Now, what else we said, that this must be positive. Why this is positive? Because the feasible direction and the gradient of f makes the acute angle, and we are considering the inner product of two vectors. One is S, that is the feasible direction, and another one is the gradient of the objective function gradient vector. Okay. Now, on the other hand, the feasible direction and the grad G1, that is the gradient of the first constraint, this is making the obtuse angle, that is why this is negative. And similarly, grad G2 also, if this is must be ST. ST, S and G2, this is also obtuse angle, this is also negative. That is why to adjust the sign, we have said that lambda 1, lambda 2 must be greater than 0 in this case. Equal to will be there if we are having the inactive constraint in the group. Okay. Since G3 is the inactive, the corresponding lambda will be 0 That is why lambda 1, lambda 2, lambda 3 is greater than 0, where lambda 1 and lambda 2 these are all strictly positive, but lambda 3 is 0 here. Now, with this idea I am going to the formal definition of the feasible direction, descent direction, etc. Now, we can say that if xk is a point which is the point within the feasible space. Here I showed you the feasible space, that if we consider the feasible region as rho, then collection of all points satisfying the constraints can be named as the feasible space. Okay. Now, we can say that if I move from xk to any direction d in such a way that xk plus alpha d, alpha is the step length, alpha d will remain with the feasible space, then d can be said as the feasible direction. Okay? That means from the figure, if I just want to tell you, say this is my xk. Okay? Now, I am moving in this direction, this is the direction, say d. And how far I will move? I will move with the step length alpha. That is why I am moving from xk to xk plus alpha d, where alpha will remain from 0 to alpha bar. Then this direction is the feasible direction. From xk, if I just go in this up to this point such that alpha is beyond this alpha value, just put me beyond the feasible space, then direction is the feasible direction, but we are not reaching to the feasible point. Okay, that is the definition of the feasible direction. Now, if I just say that Gix is the constraint where that is the differentiable function, then at the feasible point one or more inequality constraints at the, if xk is the optimal solution, then one or more inequalities will be with the equality sign, because these are all the active constraints. That is why if I consider a group of active constraints, as I showed you the example here, the active constraints are G1 and G2, G3 is not the active constraint. Okay? That is why if I consider G1 and G2, then we can say at the point, optimal point, G1 equal to 0 and G2 is equal to 0, then only these are all the active constraints. Okay? Now, then we can say that if D is the feasible direction, then grad of GIT dot D must be less than 0, where I is in the group of active constraints. Okay? I showed you. That is why it can be said that if we just take a sufficiently small increment alpha in the direction D, that is the feasible direction, then Gi of xk plus alpha d must be lesser than 0, because as I said that is a grad of Gi of this thing with the feasible direction must be lesser than 0. That is why we can say that grad of GID is less than 0 if we consider all active constraints together. Then we can show that every constraint grad Gi dot d, that is the inner product, makes less than 0, makes a half space. Okay. If we consider the half spaces of with all active constraints, then it will form a feasible cone. Here we can say that in this one we can say that here there is one plane, that is the half space over G1, there is one plane over G2 half space, and whatever, if we consider the combination of half planes in the feasible space, that will form the feasible cone. Okay. Now, we will show you more about it. Now, another part is that Now, we know that in this direction the objective functional value is increasing. That is why we can say that in this direction grad f dot, instead of S, here we are calling about the feasible direction as D, then the grad f of D must be greater than 0. But if I consider the other way, that is the just opposite to grad f direction, that means if I just consider this direction, this is minus grad f. Okay. That is why we can say that this minus grad f makes an obtuse angle with D. Thus, the descent direction can be defined as grad f dot D must be less than 0. Now, why we are talking all about this feasible direction, descent direction, ascent direction, all these directions, because in the next phase of my lecture you will see we will deal with the methodology to solve the constraint nonlinear programming problem. There we can see that this feasible direction, descent direction, all this mathematics will help us a lot. Okay. That is why we need to understand that the grad f dot D is less than 0, this is the descent direction. Similarly, grad f dot D greater than 0 is the ascent direction. Okay. We need to remember these two things together. Now, therefore, in that direction if I just move further, we will see that in the descent direction if we move further, we will see the functional value will decrease further and further. Now, I can show you one example. Now, say this is a function given to us, x1, x2 is the function for us. Now, there is a point 1, 3 within the space. Now, the direction is given as 1, 1. Direction has been given 1, 1 because from 1, 3 if we move in the direction 1, 1, for just if I consider a 2-dimensional space, okay, x1, x2 is the function, that means the function would be like this, x1, x2. This is one of the level curve of the function. Now, there is a point that is 1, 3. Say this is 1, 3, this is the point 1, 3. Now, there is a direction 1, 1, 1, 1, this is the direction. It has been said that we have to check if I move from 1, 3 to 1, 1, whether this is a descent direction for the function x1, x2 or not. Okay? Now, the function has been given as x1, x2. Then in the descent direction, just now we have learned grad of f dot D must be less than 0 in the descent direction. That is why let us find out what is the grad f for it. If f is x1, x2, then grad f must be is equal to 1, 1. Okay? That is why if I consider the grad f at the point 1, 3, then it must be 1, 1, actually this is x2, this is x1, because with respect to x1 we are differentiating and this is with respect to x2 we are differentiating. That is why at the point 1, 3, this point at 1, 3 will become 3, 1. Alright. That is why if we consider the grad f dot D, then we can see 3, 1 and 1, 1. If we just multiply, we can get the value of that would be equal to 4. That is why we can say D is not the descent direction. Certainly, this is the ascent direction of x1, x2. Okay. Now, let us deal with another example. There one optimization problem has been said. problem has been given as f is equal to minus x 1 plus x 2, all right, and three constraints are given. One constraint is g 1 is equal to given x 1 square plus 4 x 2 square minus 1 less than equal to 0. G 2 has been given as minus x 1 less than is equal to 0, rather x 1 is greater than 0. To make it in the same direction, all the inequalities we can consider this way. These are basically the non-negativity constraints for the decision variables. Okay. Now, there is a point has been given 1 by root 5 and 1 by root 5. Now, there are three directions are given. We need to find out that all the directions are the feasible and or descent direction or not. The direction can be feasible, the direction can be infeasible, the direction can be descent, the direction can be ascent. Okay. With that idea, we are just going one by one. If we consider the grad f value, certainly the grad f will come as here. If I just differentiate with respect to x 1 partially, then this is minus 1, and differentiate with respect to x 2, this is minus 1. Okay. Now, if we consider grad f t dot d 1, now my d 1 direction is 1 0, that is why it is becoming minus 1 minus 1 1 0, that is why this value is coming as minus 1. Okay. Now, we can say that if we, now one thing is that the point has been given here as x naught has been given 1 by root 5, 1 by root 5, but there is no effect on it because the gradient of f is not a function of x 1 x 2. That is why always the grad f would be minus 1 minus 1. Now, if I just move in this direction, then this will become less than 0. Then what is the conclusion from here? We can conclude that this direction is the descent direction. Because this is negative. All right. Let me do the same calculations for d2, d3 as well. Grad f d2 minus 1 minus 1, d2 direction is my 1 minus 0.5, then this is becoming minus 1 plus 0.5, that is why again this is coming as minus 0.5 less than 0. That is why again we can conclude that d2 is the descent direction. All right. Now, if I do further calculation for d3, grad f d3 minus 1 and 0 1, if we just consider, this is becoming 0 1, 0 minus 1 rather, okay, because d3, please consider d3 as 0 minus 1, not 0 1, all right. 0 minus 1, if we consider, this is becoming 1. That is why we can consider, we can say that d3 is ascent direction, not a descent direction. All right. Now, this is all about the descent or ascent direction, but we did not say about the feasible direction yet. Now, we need to check the feasible direction. One thing is that you see, if this is the point is there, now let us see which is the active constraints, because feasible direction can only be defined with respect to the constraint set. Descent direction or ascent direction can be defined with respect to the function, objective function, but feasible direction can only be defined with respect to the constraint set. If I just show you this one, you could see that the feasible direction can only be defined because this is collection of feasible points, that is the collection of points which satisfy all the constraints together. That is why feasible direction with respect to the constraint set. Okay. Now, if we see the constraint set, what we could see that this point, first of all, G2 is not an active constraint. G3 is not an active constraint. Is that? No, because minus 1 by root 5 is not being, we cannot say this is equal to 0, that is why this is not active. This is not active, but let us see whether this point is being satisfied with this or not. If I just substitute the values here, then we can say that 1 by 5 plus 4 by 5, that is x square, x1 square plus 4 x2 square minus 1, this is equal to 0. That is why we can conclude from here that G2 is the active constraint. G1 is the active constraint. If G1 is the active constraint, if we can prove that grad G1 dot D, that means grad G1 is making the obtuse angle with the direction of D, then we can say that you see, this is my grad G1. Okay. Now, grad G1 with this direction, it is making the obtuse angle. That is why if we can show that grad G1 it is making the obtuse angle, that is greater than 0, then we can say that D1 is the, Di is the feasible direction. If this is true, then we can say that Di is feasible direction. All right, let us see. Grad of G1 dot D1. Now, grad of G1 just now we have, we did not find it out. Grad of G1 is equal to 2x1 8x2. Okay. Now, at 1 by root 5, grad G1 value is coming as 2 by root 5 and 8 by root 5. Okay. That is why grad G1 at point x naught D1, this is at point x naught, in the D1 direction if we consider, then this would be is equal to 2 by root 5, 8 by root 5, and my D1 direction is 1 0. That is why we can say this is equal to 2 by root 5. This is greater than 0. That is why what we can conclude that D1 is feasible direction. Okay. Now, let me calculate the same for other D2 and D3. Two by root 5, 8 by root 5 and 1 minus 0.5. That is why it is coming 2 by root 5, okay, minus 4 by root 5. It is coming minus 2 by root 5. That is why this is negative. What is the conclusion from here? the conclusion is that D2 is not a feasible direction. Let me do the same for D3. D3. The D3 direction is 0 minus 1. If we just do it, we can say this is my coming minus 8 by root 5. This is less than 0. That is why again we can say that D3 is feasible direction. If we keep all together, in the previous case we could see that D1 is descent direction, D2 is descent direction and D3 is ascent direction. That is why we can conclude that only D1 is feasible and descent direction, or other directions are not the feasible and the descent direction. That is why for the minimization problem we should move through D1. We can conclude that. Okay? Now if we just move to again to the KKT condition, if we consider the minimization problem, minimization of fx subject to gj x less than is equal to bj, as I said, we can say the KKT conditions can be defined. Now here we are again considering there is a set of active constraints and there is a set of inactive constraints. If we consider that there are few number of constraints, k number of constraints which are active constraints, if we just make the group of those, then we can say that similarly for the inactive constraints also, if we just do it, we can say this is the first order optimality condition, because we have done the first order derivative of the Lagrange function with respect to decision variable, we are getting the first order optimality condition. And if we consider these are few calculations, I will speak more on these in the next, but one thing I wanted to tell you that del f by del x is greater than 0, but this is less than 0 in the feasible direction. That is why we can say this is positive. All right. And this is the graph of it. If this is my G1 and this is my G2, then this is the feasible direction, because not only the feasible direction, this is the ascent direction, because functional value is moving further with this direction with the positive value, and this is the grad G1 and this is my grad of G2. Okay. These are the normal direction at this point, and from here we can say that this is the minus grad f direction. And with this today I am concluding my lecture, because I will speak more on this in the next class, and I will show you the examples how to handle with KKT condition in the next class. Thank you very much for today.